Hello ladies and gentlemen, today we're going to be talking about right triangle trig. So I'm starting videos just to be on the safe side with, um, people being in and out of school because of quarantining right now. So I'm starting these videos just to help out and make sure that everybody's getting what they need even if they're stuck at home. Um, so today we're going to talk about right triangle trig. So the whole foundation of this you should already know from geometry. So we're going to be talking about SOHCAHTOA. So you should have learned this in, geometry. So SOHCAHTOA helps you with what you need to do with a right triangle when you are given the different trig functions. So the S stands for sine. So if we have a right triangle, I'm going to draw my right triangle first, sorry. And we have angle theta. Um, and like I said, it's a right triangle. The opposite is the side straight across from it. The adjacent side is the other leg. And the hypotenuse is the side opposite the right angle. So if we're trying to find sine of theta, I can find sine of theta by doing opposite over hypotenuse. Cosine is what C stands for, and that's going to be adjacent over hypotenuse. And T stands for tangent, which is opposite over adjacent. So those are the basic three trig functions you should have learned about in geometry and maybe even algebra 2. The other three we're going to talk about are the reciprocal trig functions, which are, just like I said, they're the reciprocal. So they're the flip of the original trig function. So the reciprocal of sine is cosecant. And cosecant of theta is just going to be hypotenuse over opposite. The reciprocal function to cosine is secant. So secant of theta is going to be hypotenuse over adjacent. And the reciprocal function of tangent is cotangent, which is going to be adjacent over opposite. So I can use these 6 trig functions to calculate what the value is of sine, cosine, tangent, so on and so forth of an angle. So let's look at that in a problem. So let's say I'm given this triangle, right triangle, ABC, and we are trying to find the 6 trig functions of that angle B. And the side lengths are 7 centimeters and 4 centimeters. And they give me the side length as C. So first thing we need to go through is calculate what C is, because we have side lengths for the other one. C is not an acceptable side length. We need a measurement for it in this case. So we're going to do Pythagorean theorem, which is a squared plus b squared equals c squared. So I'm going to do 4 squared plus 7 squared equals c squared. So I get 16 plus 49 equals c squared. 16 plus 49 is 65, so I get 65 equals c squared. And the square root of 65 is equal to c. So c is the square root of 65. So now I can write all of my trig functions for angle B. So sine, if I could write, that would be great. Sine of B is going to be the opposite over the hypotenuse, so 4 over the square root of 65. So we have to rationalize our denominator. That means we multiply the top and the bottom by the square root of 65. When I do that, I get 4 square root of 65 over 65. Cosine of B is going to be adjacent over hypotenuse, which is 7 over the square root of 65. And again, I have to rationalize my denominator, so I get 7 square root of 65 over 65. And tangent of B is opposite over adjacent. So we get 4 over 7. And that one's just easy. You don't have to rationalize the denominator on that one. So next I'm going to do cosecant of B is the flip of sine of B. So I'm going to take my original fraction that I got, 4 over the square root of 65, and I'm going to flip that. So I get the square root of 65 over 4. So there's nothing to rationalize on that one. Cosine of B, the reciprocal of that is secant. So secant of B is going to be the flip of 7 over the square root of 65, which makes it the square root of 65 over 7. And then cotangent of B is going to be 7 over 4. So those are all 6 trig functions of angle B. So that's how you apply your trig functions to a right triangle. So next thing we're going to talk about are special right triangles. So special right triangles are super important in trig because they can help you kind of forego the unit circle and having to memorize all of that. So I highly recommend that you memorize your special right triangles. So the first one we're going to talk about is a 45, 45, 90. So the side lengths for that are 1, 1, square root of 2. And the next triangle we're going to talk about is a 30, 60, 90. So opposite 30 is 1, so the number lengths are 1, 2, square root of 3. So 1 goes opposite 30, 2 is the longest side, that always goes on your hypotenuse, and the square root of 3 is opposite of 60. So, for example, if I want to find sine of 45 degrees, I can do that with my special right triangle. So sine of 45 degrees means I'm finding sine of 45, so I do opposite over hypotenuse, so I get 1 over the square root of 2, which simplifies to the square root of 2 over 2. If I want to find cosine of 45, we do adjacent over hypotenuse, which again is 1 over the square root of 2, which is square root of 2 over 2. And then tangent of 45 is opposite over adjacent, which is 1 over 1, which simplifies to just 1. And on the next one, if I want to find, let's say, sine of 60, so I'm finding sine of 60, there's 60. We're going to do opposite over hypotenuse, so square root of 3 over 2. Cosine of 60 is adjacent over hypotenuse, which is 1/2. And tangent of 60 is opposite over adjacent, so square root of 3 over 1, which is just the square root of 3. So that is how we use our special right triangles to find the value of different trig functions. So sometimes they're going to give us a problem where they want us to solve for x, and they're going to give us a right triangle. And they're going to give us a couple of side lengths and an angle measure. So what I need to do when I'm given a side length of x, I need to figure out what relates this angle to 19 and x. And the trig function that relates that angle to 19 and x is cosine. So cosine of 48 is going to be equal to my adjacent, which is 19, over my hypotenuse, which is x. So now I've set myself up with an equation that I can solve to find out what x is. So I'm going to multiply by x on both sides. So I get x times cosine of 48 equals 19. Then we can divide by cosine of 48. And I get x equals 19 over cosine of 48. which is going to be roughly 28.4. So x is going to be roughly 28.4. So that value is roughly 28.4. And if I wanted to find my other side length and calculate the rest of my trig functions, I could using Pythagorean theorem and SOHCAHTOA. But all they wanted us to do on this one was solve for x. So my value of x was 28.4. That's it for today's video. If you have any questions or notice any issues with the video, please let me know. Thanks so much for watching, and I hope you have a great day. Bye-bye.